Okay, I'd like to just take a second in these notes and sort of sum up what we've learned so far in this chapter. So far we've been talking about implicit differentiation. We're going to use this method for taking the derivative. So remember, we're still taking derivatives. So we're going to use this method when the y is not by itself. Take the derivative just like normal, but whenever there is a y, you need to make sure that you write dy dx when you take the derivative. Solve for that dy dx when you're done to actually find the derivative formula. Now this formula will usually still have a y in it. So we say that these derivatives are defined in terms of x and y. So let's take a look at a couple examples. Find dy dx for the following function. Now you'll notice it doesn't say in the directions anywhere, use implicit differentiation or anything like that, but that's okay. We know that we need to because we can see that the y is not by itself. So I'm going to need to use product rule because this first term has an x and a y in it. I'm going to copy the 2x squared, take the derivative of y, so dy dx. Plus, then I'm going to copy the y and take the derivative of 2x squared, which is 4x. Now separately, I'm going to take the derivative of 3y. So I'm going to have 3 dy dx, and then the derivative of 16 would be 0. Now I can see here that there are two separate terms that both have a dy dx in them, so I'm going to leave those two terms on the left-hand side. Now there is also a term that doesn't have a dy dx, so I'm going to subtract to move that to the right-hand side, and I get negative 4xy. Since both of these terms have a dy dx in them, I'm going to need to factor that out so that I can isolate it. So dy dx times what's left over would be 2x squared plus 3 equals negative 4xy. And then last but not least, you just divide. So you would get negative 4xy divided by 2x squared plus 3. And that is your final answer. Now in problem 2, we're going to practice the same process, but this time it says find d squared y over dx squared. In other words, get the second derivative. Let's start by getting the first derivative. This time I'm not going to need to use product rule, so I'm just going to do 6y times dy dx plus 6x equals 0. Again, I want to get the dy dx by itself, so since there's only one term that has that, it's a little bit easier this time. 6y dy dx equals negative 6x, and then when you divide, you get negative 6x divided by 6y. Again, I think reducing this is a really good idea because we know what comes next. We need to do this again. So let's find the second derivative now. Sorry, I did reduce it and divide it by 6. So I get d squared y divided by dx squared. Now to find this derivative, I'm going to need to use quotient rule. So low d high minus high d low. The derivative of y would be dy dx, and low squared goes down below. Now I can simplify this a little bit right away. And one of the other things that I'm going to do right away is I'm going to take this and I'm going to plug it in here since I happen to know what dy dx is equal to. So I would have negative y plus x, again it's just two negatives make a positive, times negative x over y, all over y squared. Now in order to simplify this, I'm going to multiply every term by the denominator, which is y. So when I distribute that to every term, I get negative y squared, because y times y will be y squared. These y's cancel, so I'm just going to do the x times the negative x, and I get negative x squared, all over y times y squared would be y cubed. And that is my final answer for the second derivative. Okay, I hope this helps to sort of put the whole thing together and to see the whole picture here of what's going on with implicit differentiation, and I will see you guys tomorrow.